Okay, in this video, I'm going to explore two different types of interest. One of them is just simple interest. The other is compound interest. Simple interest is simply you find the interest by multiplying the principal times the rate times the time, and you'll get an amount. You just add it back to your principal. It's fairly simple. And then the other one is compounding interest. The amount is going to be the principal times, and this is an interesting calculation. It's 1 plus your interest. Your interest is determined by how many times it's compounded per year it's being divided by. So the best way to show you kind of how to do this whole thing is to kind of work through a problem. And in the event, this is going to be raised by the amount of number of compound periods total. So this is a great example comparing these basic equations to each other. And I'll show you what I mean. In my first example, I'm just going to do a simple interest situation. My interest is equal to my principal times my rate times my time. My interest is going to be determined by taking $10,000, and they say my rate in here is 1.2%. So I got to convert that to a decimal, 0.01. I'm using dots as my multiplication. And my time, they say, is, well, I'm running this whole thing 10 years times 10. So if you take your calculator and you multiply this all out, you'll get the number 11,000, right? 200. Actually, I screwed up. That bell ringing messed me up. It's going to be, your interest is going to be $1,200. To get the total amount, you would basically add these together. We say it's the base amount is equal to the principal plus the interest. So it's going to be equal to principal, 10,000, plus 1,200. My answer for this is simply $11,200, right? Simple interest, okay? Now, compounded interest means you're basically taking the money, if we can think of it visually. If I do simple interest, let's say I have a bag of money. It's 10,000, right? And I just wait for 10 years. And then when I cash it out, it's now worth $11,200, right? When you do the other one, you take this thing, it's a bag of money once again. I'm just going to put a dollar sign on it, right? Every year, you add back the money interest it's made and use that for its next compounding period. So it will go up. Not a whole lot, but it's going to go up higher. Eventually, it gets to be quite a bit, right? So this equation is really strange looking. It's the amount is equal to, you're not going to do the separate equation for this whole thing. It's just going to be amount is equal to my principal times 1 plus the interest. Now, when we go to do the interest, you have to find out how many times you're doing it per year. And it's going to be raised by the number of years, right? So in looking at this, how you do this is simply go A equals 10,000 times 1.0. Oh, we got to figure this out though. What you do is you take, we had it at 0.012, and it's compounded only once per year. So it ends up being the same number, 0.012. So I'm going to keep it that way. So it's just 12, and it's going to be compounded for what? 10 years. So it's raised to the exponent of that. When you math this thing up, you get a different amount. A equals 11267, right? So you can see, well, that's a little higher than this one, right? This is 11200. I've made $67 more, see, between these two amounts. Why? Because it's adding back my interest when it starts to do the work on this. That's kind of cool, right? So compounding is good. What happens if it's compounded monthly instead of once a year? It's done every month is determined. You got to take that interest rate, 0.012, and now you get divided by 12. That's going to give us the number, wow, 0.001. right? That's what I'm going to use in my calculation. A equals P, right, times 1 plus I raised to the number of compounding periods. Well, since it's 10 years, but once every month, that means it's 120 times. How do I get that? 10 years times every month, just 12 months, equals 120 times. So we'll figure out what this is. A equals 10,000 times 1.001 times, in this case, 120. And if you run this through your calculator, you'll get a big number. Number for this one's going to be the amount equals 11274. Now you look at it, you might not say, well, that's not much of an increase, right? It's $7 more. So plus 7. It's because you're doing it every month, okay? So which one will give you the most? Well, it's going to be compounded monthly. Okay. So this gives you kind of an idea. It's what's going on when you do these kind of things. It's a little strange, this part right here, because you have to find out. You're saying it's 1.2%, right? But you're breaking it up over 12 months and how it's used. And where this one is 0. I guess in this case just 1.2%, right? But this is done every year, and it's going to give you a different result. Okay.